Welcome to the video presentation and demonstration of Brandon Husel's and Victor Fries's software engineering project, EggRunner, for Computer Science 476 at the University of Regina. When deciding on what to do for our project, we realized our project must offer meaningful challenge but be enjoyable and exciting to work on, and that it must improve our skills as programmers and producers of software. We decided to learn the Unity development platform and make a game for our project.
One of our biggest sources of inspiration for creating EggRunner was Super Mario Maker by Nintendo. The use of a tile-based placement system seemed like it allowed users to create complicated levels without having to learn how to use a complicated system. We liked all the unique mechanics that could be used to interact with each other in different ways and thought it would provide very interesting gameplay if we tried to mimic something like that. Our biggest functional requirement was the ability for players to create their own levels based on a set of tile sets, and players also needed to be able to save those levels to our server and then access other levels created by other players and play them on their device. For each level, we wanted to record the highest score that had been scored on it so that players could see them when selecting the level they wanted to play.
Design patterns are an important concept in software engineering. They allow developers to organize their workflow, and they promote code to be designed in ways that are lowly coupled and highly cohesive. We made heavy use of the spiral design pattern with an embedded prototyping pattern within. Following the spiral model, we would come up with a game mechanic to add, then use the prototyping model to create a lo-fi version of this mechanic. We then evolved this mechanic to properly integrate it into the game as a whole, and finally ensure quality in both the game and editor, and then we would repeat this cycle. This ensured, after every cycle, we had a working product of a game regardless of the deadline. We also incorporated the mediator behavioral pattern to help with our game object hierarchy. This helped to create high cohesion in our game objects and code. It allowed communication to travel vertically and ensured shared coordinate systems amongst our game objects. We called our mediator the Game Manager. Our Game Manager was also the point of contact for how our save the level system told the game where to place what objects, acting as a single, low-coupled line of communication. Here we see how our Game Manager instantiated doors on the left, as well as how our game object hierarchy looked on the right. Object locations were stored in arrays. Upon starting a level, the game instantiated the correct object at each location and held onto them in arrays. Here we see the C# scripts attached to the Game Manager and an example of how the Game Manager mediated objects on the right.
The level editor uses multiple arrays of tile maps to store all of the level data. When a user places a tile, it's automatically placed on the proper tile map in the right layer. When a user saves a level, it's automatically converted to a string, which is then sent to the server and stored in an SQL table. To organize the different placeable tiles for the user, there's a number of tabs on the left-hand side. Grass, ice, and stone each represent different types of terrain the user can place, while the Details tab holds specific unique elements. To select a tile, the user simply has to click on it, and then they can click in the world to draw it on the screen. You can right-click a tile to delete it in the world, and you can middle-click one to select it as your current tile, which is useful if the user accidentally deletes one and has a similar tile located nearby. I'm now quickly going to demonstrate building an entire level from scratch, just to show you how it works. The bridge tiles I'm placing right there only allow collisions from the top, which is a pretty common platform mechanic. That green slime object is a little monster that will run around and attack the player. The eggs I'm placing are just a collectible that gives the player points as they pick them up. That door needs to be unlocked by collecting a key, which I placed on the other side of the map, and that dark gray material there is an underground material that has no collisions with the player. It's used purely for decorational purposes and is rendered behind all other objects. And here's the finished level. Now all that's left for the player to do is save it, enter their name, and upload it to the server so that other people can play it. On the Unity side of things are pretty simple. There's a canvas layer to represent the entire user interface that holds the panel for the left menu where the user can interact with all the tile buttons. There's also the top menu here that holds just some standard buttons. You might notice that there are no buttons in the UI element currently. That's because there were so many tiles I didn't want to have to create all of them individually. And so I wrote a script that can take all of the tiles in the game and procedurally generate the buttons to set them as your current tile. Each panel tab here has an attached script that generates buttons when given an array of individual sprites. And so if you wanted to add a new element to the grass tab, for instance, you could just add a new sprite map texture to this array here. The code here is actually pretty simple. It basically just creates a button, sets its texture to the sprite, and then does that again for every single sprite that it's been provided to it in its array. The script that actually handles placing tiles is right here. It basically takes a tile map for each different layer, as well as a array of tiles, which layer each specific sprite will be placed on. There's some other specific variables used for setting the starting location when compressing the map to a string. Essentially, the file looks for the user's mouse input, and when they click, gets their current position in the world space and sets that cell to whatever tile they currently have selected.
Now let's play that level Victor made for us. You'll see to the right the purple slime is jumping around, trying to get to us. Looks like he can't. We can jump up through these bridges and it won't make a collision, but we will collide coming down, meaning we can jump through them and stand on top of them. Let's gather eggs as we go to the right. Notice the parallax effect with the mountain and the sky in the background, below our hills that have the same effect. Let's get to this coop. Uh-oh, can't get through the door. We'll have to find a key to open that door up. We'll head back to the left, gather more eggs as we go. Notice the little +1s that appear as we collect eggs. You can see the score in the top right. Now we have 20 as our score. Hey look, there's the key. Let's go grab it. We have collected the key. Nice, you can see it in the top. We made a collision with a slime and our player's sprite turned red and he took damage, again with the spikes there. Notice how we only have 1 health left in the upper left. We should be able to get to this door now. Opens up with the key, and just like that, we've won the level. Now let's start this new game. We start in a pit with 2 slimes trying to get to us. Darn, these slimes sure can be annoying. Let's exact revenge. See the power-up on the right, a glowing piece of bread. Now that we've collected it, we can dash with the spacebar. Dashing into slimes destroys them and earns us 15 points. Another feature of our game is as we fall, the camera will begin to pan down so we can see more below us. If we fall below the lowest tile in the game, that's a game over.
EggRunner follows a very standard 3-tier server architecture. All of the program's web files, as well as its PHP scripts, are hosted on a web server at the university. When the client needs to make a request to the server for information, it simply accesses one of those PHP scripts, which is run on the server. This then interfaces with a standard SQL database to retrieve whatever is required, be it level information or submitting high scores. This class diagram here represents everything that was necessary for the level editor to work on a functional level. Unity's inherent design hierarchy really helped to encourage an encapsulated object-oriented system and really improved the readability of our program. Due to time constraints and an unforeseen global catastrophe, we weren't able to implement everything we would have liked to in our final implementation of EggRunner. Something we were really excited to design were unique enemies and power-ups that would allow players to interact with the levels in different ways. We were only able to actually add the one power-up that you get by eating bread, but the code is all there to allow for an easy implementation of new power-ups or enemies, as well as different terrain tiles if needed. A level voting system is another thing that would have been really nice to add, as it would allow popular and interesting levels to be seen easier than simple and boring levels that were made quickly. The main reason this wasn't added was because it would require a actual user database system to manage accounts to prevent people from voting more than once, and this seemed a little out of the scope of our initial plan to design the game, as it had nothing to do with the actual gameplay itself. Thank you for taking the time to listen to our presentation. We hope you check out the game for yourself and maybe even create a level or two.